Okay, so before we got going today, I wrote a super short program in Mathematica. So I defined n equals 2, so we'll go up to the second order term.
Mm-hmm.
My function of t is defined to be a sum of it to the k over factorial k. K goes from 0 to whatever n is. So, and then in the sum definition in Mathematica, the lower bound and upper bound are included. So when n equals 2 here, what is my Taylor series approximation for e to the x when
so
n equals 2?
1 plus x squared over 2.
That's right. So I go up to the x squared over 2 term, except here I'm doing I times, well, t I said, over 2. And then I did a parametric plot where the x coordinate was the real part of f of t, and the y coordinate was the imaginary part of f of t. And for now I'm looking at t going from 0 to 2 pi. So here's our approximation with n equals 2. And what I'd like you to do is just have you play around with this and see what you would want to do. And there's lots of, there's a handful of different things you can change. And obviously we're not going to animate this. We'll just look at the static pictures.
So this is going to make our circle. So let's just see, first off, if we go to 20, we should see the circle, but we should see the rest of the reals beyond 2 pi still not conforming to the circle.
All right, well, let's see what happens. Okay.
Okay, so I guess we were going, oh yeah.
Can you zoom to 150, so our circle actually stays on the screen here. Okay, yeah, so
we were going from 0 to 2 pi?
Yeah, so actually this is a nice first start. We're locked in on 0 to 2 pi.
So,
but at 20 we do see something that sure looks an awful lot like a circle.
Maybe let's go to 3 pi and see what that looks like.
All right.
So there's the circle that we saw before, and then the numbers beyond 3 pi, or beyond 2 pi, don't quite conform, and then loops around.
Yeah. Okay. So interesting. So it's interesting that he stopped at 20, and 20 is a good approximation from 0 to 2 pi, but it even breaks at 3 pi, which is kind of wild.
So maybe how many terms would you need to do 3 pi? Maybe let's try 30 terms.
So nice.
Seems to work. Do we need that many terms? Maybe 25 terms. Not quite.
Oh, that's cool though. At 25, it nearly works. See what? Yeah, cool.
Yeah, so maybe looks like you still see it. Yes, 26 or 27 is where it all works.
Yeah, visually it looks okay. It would be interesting to sort of study what the errors look like, but it's not bad.
Yeah. That's interesting. Let's see. Maybe what happens if we go back to 2 pi and we go minus 2, or maybe just minus pi to pi.
Okay.
I'll go back to like 2 terms.
Oh, nice. Okay, so that's a great thing to look at. So the surprise before was that at 2 terms we saw one thing. If we go 0 to 2 pi, sorry, I'm not quite sure what I lost the point I was making. But yeah, now it actually kind of looks like what?
It looks like kind of twice what we saw before. We have this part, we have the reflection kind of.
Yeah, and it's sort of a sideways parabola, but the interesting thing is that it's actually what it's actually going to turn into is sort of more circular.
So this should loop down and this should loop up.
Okay, so
let's go to 10. Yeah, that worked.
Oh, cool.
Intermediate step, yeah. So here's like a quarter circle here and a quarter circle here, and then these don't quite work.
Oh, that's neat. Yeah, that's a cool idea.
And there's kind of almost, and that's curve back in, and then And so you can see it's not quite right on this side. And then
Yeah, it's darn close.
10 it seems to be visually pretty good.
Neat.
So yeah, minus pi seems to behave, or at least the negative pi's seem to behave kind of opposite of positive pi's. So this if we don't go to a multiple of pi, it should still wrap around.
Yep.
Can't really change this. This is these.
Yeah, I don't want to change the function, but
Yeah.
see how many it takes to get, let's say 0 to 6 pi, or if you want to do minus 3 pi to 3 pi, either one.
T0 6 pi. So
So at 10 terms, we're just heading off to infinity. In fact, maybe there's a circle there. In fact, we kind of know there's a circle there, but it's sort of lost.
yeah. So I think my first guess would be 60 terms that we'd need. And seems to be about right.
All right, why'd you guess 60?
Well, for 2 it took about 20. For 3 it took about 30. So I thought it would take 60.
Okay.
I noticed but if we do minus 3 pi to 3 pi, for minus pi to pi this only took 10, so this should take half the terms. It should only take 30 terms.
Oh, look at that.
It's interesting.
Yeah, what happens if you do 0 to 6 pi with 30 terms? What does it look like? Or before you even hit return, what do you think it's going to look like?
I think we'll have a circle and then kind of a line going off to infinity somewhere.
Okay.
Yeah, I mean, you can sort of see that there's a little circle there,
Yeah.
and then it just goes up.
Okay.
Even at 50 terms, it's pretty close.
Yeah, that's pretty cool.
55. I guess you don't need quite 60 terms.
Yeah, but actually your heuristic's pretty good. Try 10 pi. So what's your initial guess for 10 pi?
Initial guess would probably be 100.
All right.
So here's 55. I mean, you can't really say anything. At 100, we're good. Now maybe 90 terms. Even at 90, we're okay. So seems like it's slightly less than 10 terms for every pi you go up.
Yeah, that's interesting. Okay. Try 20 pi just for giggles and see.
So 20 pi, I'm gonna say 180 should be plenty. Oh.
Okay.
So
this is actually what I was hoping would happen. What do you think is happening here?
Something's breaking.
Yeah, what could be causing problems here?
And maybe the 180 factorial.
Yeah, we're inside of the sum. We're actually raising things to the 180th power, and then dividing by 180 factorial. So we're starting to, get to the limits of
Computing power.
Of the precision that we can compute.
I mean, obviously this is not right because you couldn't. Like these lines you really couldn't make.
Yeah, it's the problem is when you're raising things to super high power. So to make these parametric plots, it's just kind of stepping along with some little small step.
But your steps are so big even at the small steps.
Yeah. So
I mean, can we even get it to look like anything? Not really.
Yeah. But anyway, it's cool. We can see that we can break it by going to 20 pi, but we saw that we actually could have a function that winds around a circle. And it's actually really neat to see. It's a fun way to review. It's a fun way to review some calculus ideas and then also kind of see, actually right at the end here, some limitations of computers.
Yeah.
Cool. Good job, Ben.